This is the IJobEntity Job structure, and it was just released with the entity's 0.50 update. IJobEntity is the second easiest way to do a data transformation in Unity ECS, only behind entities.forEach. However, they have many advantages over standard entities.forEach that just might make you consider using them over entities.forEach by default. So today I'll be going over the quirks and features of IJobEntity Jobs, and then I'll be taking it out for a drive and showing you how they work in the sample projects you see playing behind me. And as per usual, down in the description below, I will have links to the sample projects as well as the code featured in today's video, so you can reference it and implement these on your own. By the way, I recently did change up the way that I actually am providing you these sample projects. In the past, I was kind of just giving you like a Unity package and you'd have to, load that into a new project. Now I've actually kind of changed it, so I'm basically giving you the project files minus like the library folder and stuff like that. So basically you can just kind of, load this up into your Unity hub, point to that directory that you downloaded from me, and then you can open up your project, and it should include, all the extra dependencies and everything like that, because I know some people were having some issues with it earlier. So now I've kind of changed things up a little bit. So again, do check out those project files and let me know how they work out for you. Okay, so real quickly, I'm just going to show you my setup in Unity. Of course, I have an entities 0.50 project set up. If you do want to learn how to set up a new entities 0.50 project, I will have a link to that video that I made up in the card as well as in the description below. But anyways, you'll see that I have a pretty simple scene here. I kind of just have like this little road set up, and then you'll see that I have 3 different capsules here. So this green capsule, if we take a look at what it has, you'll see that it has a move speed as well as a convert to entity script on it. The next capsule has a move speed as well as the special move tag. Of course, this is being converted to an entity as well. And then finally, we have one that has the convert to entity script on it. It also does have that special move tag, but it does not have a move speed component. And so we'll be getting into kind of the differences of this little setup here. So anyways, I think the best way to explain what these IJobEntity jobs are and how they work is to really just kind of go through the process of creating one and showing you these things along the way. By the way, if you're already familiar with using entities.forEach functions as well as scheduling jobs using the C# job system, these IJobEntity jobs are going to be very familiar for you. So really at the core, an IJobEntity job is just another way to, iterate across data and make transformations to entities along the way. So let's go ahead and start out by defining one. So this is kind of similar to a job where we're actually going to define this outside of our existing, say, movement system, which is a system-based class here. So we'll just go ahead and create a public partial struct. In this case, we'll just call this the move job. And of course, it's going to implement IJobEntity. Now, a couple things that you'll notice here. One, we do need to use this partial keyword because it actually does take advantage of source generation. Basically, these IJobEntity jobs behind the scenes, they're going to generate an IJobEntity batch job. By the way, I did do a video on IJobEntity batch jobs. You can go check that video out if you want to learn about how those work. But this IJobEntity is really just going to be a nice, easy wrapper around the IJobEntity batch for us to use. Also, I should mention that if you're curious, you can actually inspect the generated code in the project directory just by going to the temp and then generated code directory. And then in there, you'll find all the generated code files, including the IJobEntities converted to IJobEntity batch jobs. So anyways, very similar to just like a regular job, we'll need to create an execute function here. So as you can see, this is looking pretty similar to a regular job that we might schedule in the C# job system. However, key difference here is actually inside the parameters of the execute function, we can define our entity query very similar to how we would in, say, an entities.forEach function. So in this case, we can just say, ref translation, we'll call this translation, and then we'll also look at an in of the move speed. Again, we can just call this move speed. Now, one key difference here between this and an entities.forEach is we don't have that 8 component limit. We can actually define as many components as we want inside the parameters of this execute function. Of course, with entities.forEach, there is an 8 component limit. Now, there are some ways that we can actually get around that. However, just out of the box by default, the IJobEntity supports more components than just 8. And then of course, inside our execute function, we can go ahead and read and write to these based off of the parameters. Of course, the ref is going to mean read and write access, and then the in is going to be read-only access. Now, in this case, we do want to update our translation.value. Just go ahead and do a plus equals, and then we'll do a math.forward, and then we'll go ahead and multiply that by our move speed.value. Now, of course, this thing is just going to take off like a complete rocket, so we do need to actually multiply by a delta time value here just to normalize for frame rates. And then, of course, because this is just a regular struct, we can go ahead and create a public float, and we'll call this delta time. Okay, so this is basically our simple job here. There's not much more that we need to do here other than we can just go ahead and actually add the burst compile attribute on there. If we don't include this, then that job will not be burst compiled. So we definitely do want to take advantage of the burst compiler when it is available to us. So now the job is completely set up. Of course, at this point, it's not actually going to do anything because we still need to actually schedule this job. So we can actually schedule this job from any system-based class. Unfortunately, this does not work for MonoBehaviours. We can't schedule an IJobEntity job for MonoBehaviours. The reason being is because it doesn't set up the proper dependencies when we define or schedule the job from a MonoBehaviour. So we just want to make sure that we're actually, defining this job and scheduling it from system-based classes only. So anyways, we'll do this inside our onUpdate function because we want this job to run every single frame. Let's just go ahead and create a new move job. In here, we'll go ahead and set our delta time equal to time.delta time, just like that. And so of course, that's going to create this new job. Now after this, we can just go ahead and do a .run, and this of course will just go ahead and run it on the main thread. So you'll see that again, every single frame, we're going to create a new one of these jobs. We'll go ahead and assign delta time and just run it on the main thread. All right, so you'll notice that we actually didn't need to do any special entity queries or anything like that. So when we just go ahead and run an IJobEntity job just like this, it's actually going to use these parameters inside the execute function for our query. So in this case, it's going to look for anything with a translation as well as a move speed component, and it's just going to go ahead and perform those operations on them. So now at this point, we can come back to Unity and we can just go ahead and enter play mode here, and you'll see that the green and the yellow capsules are just going to go ahead and move forward because those are the only two that have both the translation as well as a move speed component on them. Okay, great. So let's start getting a little bit more complicated with this. So instead of doing a run, we can actually do a schedule or even a schedule parallel. So of course, just similar to a job, we can run it on the main thread, or we can schedule it to run on a worker thread, or schedule it to run it in parallel. So really up to you, kind of depending on what you need out of the game. All right, so now let's start to get a little bit more complex with this. So now I've gone ahead and created this regular move query. You'll see that we're going to go ahead and create a new entity query. And so we're looking for anything that has read and write access to a translation. We do want read-only access to move speed, and we're going to exclude anything with the special move tag. So now that we have our regular move query here, we can actually just go ahead and pass this into where we're scheduling our job. So this works for run, schedule, and schedule parallel. Just go ahead and pass in a move query just like that. So now when we come back to Unity, we can go ahead and enter play mode, and you'll see that now only the green capsule is moving. That's because we're again excluding anything with that special move tag, which the yellow one has. All right, so now let's get into one of the main advantages of these IJobEntity jobs. Now the great thing about these is they are actually infinitely reusable. So of course, because this struct is defined outside of our system, from any system in our game, we can actually just go ahead and define a new move job and schedule it based off of an entity query. But that does actually allow us to do some pretty cool things here. So instead of actually scheduling this, I'm going to go ahead and take that out. So we're basically just creating the new move job here. So let's go ahead and just store this in a variable called new move job. And then now under here, we can say our new move job dot schedule parallel. Again, we'll just go ahead and pass in our regular move query. So in this case, that's just going to go ahead and move that green entity. Now let's say we also do want to move that yellow entity. Well, similar to before, we could just go ahead and do this new move job. And again, we'll do a dot schedule parallel. And this time we won't go ahead and pass in an entity query. Now, if we come back over to Unity, we're going to go ahead and enter play mode, and something interesting is going to happen. You'll see that the green capsule is going a little bit faster than the yellow one. So it's actually going about twice as fast. If we continue moving it, you see that it just keeps going further and further. Reason being is because if we come back to our code here, let's take a look at what exactly is going on. So we're actually going to go ahead and run the move job on anything that matches that regular move query, which in this case, again, is only that green capsule. And then we're also going to do a schedule parallel, and then we're not going to pass in any entity query. So again, that means we come down here to our execute function, and then we're looking for everything with a translation and a move speed. So if you kind of think about what's going on, it's actually going to be scheduling this job 2 times on that green capsule because it's going to fit under that regular move query as well as the query defined in our execute parameters here. So that definitely is something that we need to be aware of. Just make sure that we don't have like overlapping entity queries, because we could accidentally be applying a job to a particular entity twice. All right, so now to get around that, I've just gone ahead and created this special move query. And then of course we can just pass this in right here. And then of course, in this case, again, the green and yellow entities are just moving at the same speed. So now let's start to get a little bit more interesting with this. Let's say we want to do something different with the special move query. So let's think of a scenario where maybe we have like a racing game and we want to slow down all the entities that have a particular tag. Maybe one racer picked up a particular item and then that slows down, all the other cars in the game. So basically, what we can do here is we can actually go ahead into our move job. Let's go ahead and create a new field here. This will be a public float. We'll just call this move mod for our move speed modifier here. And then at the end, we're just going to go ahead and multiply this by our move mod. All right, so now back to our update function here. Let's just go ahead and set this move mod equal to 1F by default. So then we'll just go ahead and schedule it on our regular move query. All right, so now what we can do here is just go to our new move job, and then we can just do dot, and then we can actually set our move mod. So in this case, let's set it to say like 0.25. So now we're going to run the job with our regular move query. We're going to change our move speed modifier, and then we're going to schedule that job against our special move query. So now if we enter play mode, you'll see the green capsule is moving at its regular speed, and now the yellow capsule is moving at only a quarter speed. So again, this is really cool because we just defined this one single job, and now we can, call this job from multiple places with different implementations. So this is, really handy stuff. Now, before we move on to the other demo, I do want to point out one interesting thing. So in this case, I've gone ahead and created this invalid query. So you'll see that it's looking for everything with a special move tag, but it does not have the move speed component. Now, this is going to be a problem because again, this job does require this move speed component here. So now let's see if we go ahead and do a new move job. Again, we'll schedule it parallel, and this time we'll pass in the invalid query. Well, you see we don't get any errors inside our IDE. If we come over to Unity, again, you'll see there are no error messages in the console. However, if we do hit the play button, again, because we do have this red capsule that does have that special move tag, but it does not have the move speed component, you see that now inside the console, we're getting all these null reference exceptions because it basically finds that entity, but it does not find the particular move speed data component on it, because again, that job does require the move speed data component. So again, that's really just something that you need to watch out for. If you are defining any specific components inside your execute parameters here, just make sure that you include those components inside your entity queries so you don't run into a situation where, it's trying to access entity data that's not actually on that entity. Okay, so I think that initial demo gives you a pretty good idea about, what exactly these IJobEntity jobs are and how they work. Now, with this one, I just wanted to show you something maybe a little bit more interesting that you could do with these IJobEntity jobs, maybe something a little bit more practical than just a simple translation job. So as you see, we have this IJobEntity battle arena. You'll see kind of over on the left, we have team 1, and on the right, we have team 2. Now, basically what's going to happen is we can select either damage or heal. We can select which team we want to apply it to, if we want to do team 1, team 2, or all. And then we can go ahead and select the, amount of damage that we want to apply. So in this case, let's say, 12 damage. So 12 damage on team 1, go ahead and execute. You'll see that now the health bars go down by 12 of these, each time we press that button. And then now we can actually go ahead and say heal this. Let's go ahead and, heal these by like 50. Go ahead and heal them, and they all come back to life here. Now let's go ahead and damage team 1 by 50. You see that we have this, top guy, it's grayed out now. And if we try to heal it, you'll see that the other ones heal, but you'll see that this one, because it's out of health, it's not actually going to heal. And then, similarly, we can come over to team 2. We can try and heal them, but they're all at full health, so it's not really going to do anything. If we come over here, let's go ahead and say damage these guys by 30. Say execute, and you'll see that, all their healths go down by a value of 30. Of course, we can come over to here. We can say all, let's damage everything. Let's say damage everything by not 315. How about just 15? So we'll say execute. And then you'll see that now everything goes down, 15 below what it was before. Of course, we can heal everything. And this is just going to go ahead and heal all the battle entities that are still alive here. So, pretty simple. Again, this is just using one single IJobEntity job. So let's get into how that's set up. And once again, all the code and project files associated with this sample project are available using the links in the description below. All right, so you see here that we have our perform spell job. Of course, it is a public partial struct implementing IJobEntity, and we do have the burst compile attribute on there. So basically the way this works is it's going to take in an int for the effect amount. So that's how much it's either damaging or being healed. We're also taking in an entity command buffer parallel writer. That's so that, we can do a schedule parallel on this job and write any structural changes to an entity command buffer. Now you'll see here in the execute function, very similar to an entities.forEach. First parameter, we can actually go ahead and define the entity. So this gives us access to the exact entity that we're iterating on. Now the next parameter is a little bit different. So, previously we had to say int, and we called it entity inquiry index, and the int had to be called exactly that. Now it's a little bit different because we can actually call the int whatever we want. You'll see in this case, I've just called it sort key because I think that's, a little bit more clear about what it is rather than the entity inquiry index. However, we do just need to add the entity inquiry index attribute right before that sort key there, just so everything gets set up properly. And then finally, we're just doing a ref to the hit points here. And then so you'll see what we're doing here. We're basically just setting the current hit points. If the hit points is less than 0, it's going to go ahead and add the destroy entity tag, so a couple cleanup operations can happen up later. And then we're just setting the current hit points, same thing like we would anywhere else. So that's the job. Now I did initially want to schedule this from a MonoBehaviour, but as you remember, we can't actually create or schedule these jobs inside of a MonoBehaviour. So basically what we do here is we just kind of have reference to all our UI elements here. And then we press the execute button. We're just going to grab, the values from the different, text fields and everything like that we have. And then we just go ahead and pass these into a data component, which I've called this spell execution data. And it's just going to add that to this spell controller entity. And so the reason we do this is because it's, easy to get UI data from a MonoBehaviour. Again, we can't schedule the job from a MonoBehaviour. So we do just need to, package up the data that we need and then send that over to the ECS side. So now over on the ECS side, you'll see that I have this system here. So it's going to be running only when we have this spell execution data singleton, which of course is that component that we just added from our MonoBehaviour. And then you'll see basically inside the on update, of course, we're just going to go ahead and create an entity command buffer here. And then we're going to go ahead and get the data from our spell execution. Now here's what we're going to do here for our entity query. We'll just do a battle entity query, and then we'll create a new entity query looking for anything with a type of hit points and a team ID. And then we're going to go ahead and just do a quick switch on the spell execution data's team ID. Basically what's happening here is in the dropdown, if the value is 0, that's the first element, which is basically the value of team 1. So in this case, we're just going to go ahead and set the shared component filter for team 1. And then, case 1 is going to be the second element, which equates to team 2. And we'll just go ahead and set our shared component filter to team 2. If you're not really sure about what's going on with these shared components, definitely check out the video that I did on shared components to learn a little bit more about those, because shared components are extremely useful. So basically that just filters out our entity query, and then we'll just go ahead and create our new spell here. You'll see that we're just going to pass in the effect amount that we got off that data component, and we'll also just pass in our entity command buffer, and we'll just go ahead and do a schedule parallel on our battle entity query. And then at the end, we'll just go ahead and remove that singleton just because we don't want this running every single frame. So once again, we can just kind of come back over to Unity. Again, we can say, damage. We'll go ahead and damage all. Let's go ahead and damage them all by, say, a value of 10. Go ahead and execute. You'll see that everything goes down by a value of 10. In this case, let's go ahead and just heal team 1 by 10. So team 1 is going to be healed, and then team 2 is going to stay damaged. So anyways, that is an overview about how to use these IJobEntity jobs. Really curious to learning more about, what you think of these IJobEntity jobs. Do you have any particular use cases in mind that these will be extremely useful for you? Definitely let me know those down in the comments section below. And before we go, I do just want to give a major shout out to Danny. Danny is over in the Turbo Makes Games Discord community, tmg.dev/Discord, by the way. Anyways, Danny is a software developer over at Unity, and he was part of the team who created the IJobEntity. So this is, something that he's been working on for a long time and has been very excited about. And he's just been extremely helpful for, helping me figure out how to use these IJobEntities and some of all the, weird little quirks and stuff in them. So definitely, I know he's open to hearing your feedback about, how you want to use these, if there are any improvements that could be made, because again, this is, just the first time that this feature is out in the wild now. So, definitely take a moment to, go ahead and use this, play around with them. If you think there's anything that they could do better, definitely feel free to let myself know, or, just shout out Danny over the Discord. Now, of course, I know there were definitely other people involved with bringing the IJobEntity to life. So, shout out to them. I'm definitely a really big fan of this IJobEntity. And, as I've been playing around with it, I'm like starting to see, like all these cool ways about how I can kind of, reuse them in some of my different projects. So, definitely stay tuned for more on IJobEntity coming soon. Anyways, I do hope that you enjoyed today's video and you found it helpful. If you did, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system and their data-oriented technology stack. Of course, if you do have any questions or suggestions for future videos, definitely feel free to leave those down in the comments section below, or join us over on Discord. Once again, that's tmg.dev/Discord. I hope you all have a fantastic rest of your day, and I'll see you in the next one.